This week, a few more crystals have grown on top of the old ones, and they are slightly larger in size. I have kept them on my desk away from the window or heater so that ideally it is at room temperature constantly and will not be affected by the elements. In order to calculate the percent yield of the reaction, you first have to find the limiting reagent. In this case, it is aluminum. We started with 1.015 grams of aluminum, which you then divide by the molar mass of the aluminum to get the number of moles of aluminum in the reactants. Then, because the molar ratio of aluminum to potassium aluminum sulfate is 1:1, you can multiply by the molar mass of potassium aluminum sulfate to find the number of grams of potassium aluminum sulfate as the theoretical yield. In this case, it is 9.71 grams. Then, to actually calculate the percent yield, you must divide the actual yield by the theoretical yield and multiply by 100%. Our actual yield was much greater than the theoretical yield, giving us close to 200% as the percent yield. So how did that actually happen? I think the reason behind this yield is that this is an equilibrium reaction, meaning that it continues to run unless acted on by an outside force. Also, this is an exothermic reaction, which means that by placing it in the ice bath to cause the potassium aluminum hydroxide to form, we shifted the equilibrium to cause it to create more products.